Hello and welcome to a long-awaited stream.
Hi again.
Today with Andreas
Moritz!
and of course his favorite topic, Quarkus
Yeah.
and Helm. All
Yeah.
right, what are we doing today?
I wanted to continue with my series that takes months because somehow it gets split up a lot. About Helm Charts. If you remember and if you don't remember, have a look at the YouTube videos where you can get everything again and recap it. We started with building Helm charts. We created a container with Quarkus and chip, and everything we built with GitHub Actions. And today we want to finalize it by using GitHub Actions and Helm to deploy it on our Kubernetes cluster and get everything running, fully integrated, so we have real fun with it.
Nice.
Yeah.
Okay.
So
should I share your screen?
Yeah, you can share my screen.
Ooh.
Yeah. First of all, as always, we have a new Quarkus version. New version. Also, I realized that we are still using Java 11, which you can still use with Quarkus, but we could also upgrade. So I thought as a starter to get back into it. Oh, I need to increase the font size.
I think you have to increase it a little bit.
I always forget.
Perfect.
That helps.
Yes.
So
just for the versions, this is not a major, this is a minor version, right?
Yeah, minor version.
Okay.
Quarkus had only one major version switch, and they actually do not really want to make major versions.
Okay.
They always aim to make only minor versions, where it's basically non-breaking, or they deprecate stuff for really a couple of versions, and then one day remove it when they have a real replacement for it and it's fully tested and so on.
Okay.
And there was only one time the switch to 2.0 when there were really major changes, but they usually don't want to do that. Okay. That makes it easier for us to update, obviously. And if we always stay on track, we never have really big problems. So now we want to update Quarkus. We see we are on 2.11.3 and there's 2.13.3. Wow. I might have actually always typed 12 when I tested it. So
this would be nothing major changing, but just additions, right?
More or less. Additions, okay. Bug fixes, yeah.
Okay.
When you really want to know it, then you go to GitHub Quarkus, and you can go to the releases here.
Oh, okay.
The last one is 2 days ago. And here you see the complete changelog with the link to the tickets or pull requests. And this is the last minor version probably for this, patch version for this minor version. Because usually at the beginning of the month you get a new minor version. That's like the schedule. And you see that's really big. And usually a new version has, they usually have a lot of changes.
Okay.
So it's quite interesting always to have a bit of read through it. Most of the stuff also doesn't influence me because there's a lot of extensions and you don't need all of them. But it's always good to have like a look at it and see if something has changed. Yeah, maybe I should fix the camera. No, wrong direction.
What do you do?
Yeah, it was broken already.
I think you have to pull the monitor towards you a little bit.
Nope.
Too much.
No.
Zoom in.
Okay.
Okay.
Okay. So let's try that. So I just increased the Quarkus version here. One thing that changed is that we now have Kotlin 7.20. 1720. So We can also change that here. Sync everything. Then I said we want to go to Java 17. What happened? That was a bit much. So let's just update this here. Also, let's check Gradle. Yeah, that's like 5.1. Why not? All the new goodies. And then here, when we, this is the pipeline file for GitHub Actions. Here, initially we say we want JDK 11. Now we want 17. And I think if I didn't forget anything, then it should be it. Let's see if it builds here. And then I will make a quick commit. Oh, it's stream 12 already in this series. That's nice. So yeah, of course it has to be to download everything, building. Yeah, but basically that's like the most you can upgrade anything. We changed the Java version, we changed the Gradle version, we changed the Quarkus version. That's, and it's really not that much that you have to do. And again, since we get all the dependency versions with the Quarkus version together, we don't have any versions here, so it all works together, and they tested it together. Yeah. The build is taking really a while now. Ah, there it comes. Probably downloaded a lot. I also have already pushed it. So we also see here the build running and GitHub Actions.
Nice.
Yeah. So to recap, we have here the we now have set up JDK 17, then we assemble, basically building everything, then we run the tests with Jack, and then we build the container if that worked, and we log into the container registry on GitHub and we push the container there, and then yeah, some post-processing of the GitHub Actions that's actually automatically generated. So this will hopefully work. So let's
remind me again, the GitHub repository you're using for the container, that's private?
Yeah, again, I didn't manage to, so we have company rules currently, or settings, that no public repository can have public containers.
Okay.
I wanted to change it before this meeting, but then everyone was in a meeting, and I had no admin access, so I couldn't do it. So again, we use the container with the same code. I prepared it already in my private repository. It's like yeah, my reference. Yeah, it's the same code. We use this container here because this is public, and later on I will finally change this to get this working there. So it's the same code, it's just another address basically.
Okay.
Yeah.
One more question, because I saw that you have different versions. You also have a latest tag on it, right?
Versions for what? Do you mean?
For the
container.
The container, yes.
Yes. Yes. So I have the latest tag and always the git char.
So you don't have any version numbers on it, right?
No, I currently don't have version numbers. You could also do that. Like you could check in your GitHub Actions when there's a tag, maybe. Then you could also tag the image with the same tag.
Okay. You can use two different tags, like latest and number.
Yeah, that's what we actually do. So here we push the container and we say Gradle build. Without the tests, we push it. We say the group is repository owner. The image name is the name of the repository. You could also change that. We push it to GitHub.io, and we have an additional tag, which is the GitHub chart.
Ah, okay.
And you could add more here, like v1 point something, or you could use it from
use a tag from the
tag
commit.
from-
Okay.
I don't know if GitHub exposes something like the char here, because these are basically variables provided by GitHub.
Okay.
In the GitHub actions. We could have a look. Action.
And the latest will always be the latest, or do you have to say, okay, this is the latest?
I actually do this manually. I have this configured here in the default config, basically in the application properties. Where's container image? So the image tag is latest.
Okay.
That's just something I configured here. That I don't have to also provide it there. And it's a default value that makes sense if you build it locally or so.
But how does the previous build know that it's not the latest anymore?
Docker, when you push a new latest, then it replaces the.
Okay.
It's always
perfect.
when you push a new one, that one has the tag.
Okay. Nice.
So it basically steals it.
Okay.
Is there something like tag GitHub ref fully on ref of the branch or tag ref name? So GitHub ref type. Yeah, you could see if you build for a tag or a branch. So you can also configure that the GitHub action should only run for tags. So you could say only when I add a tag with a pattern like a release and the version or so, only then run the deploy pipeline.
Okay.
Or the push pipeline task, and only then you can then use the tag or so. But there's also other ways you could run a git command and get the tag from that also.
Oh, perfect. Yeah, sorry for the...
Yeah, no worries, no worries.
Yeah.
It's a good recap. Let's see, the job should be done by now, or failed. Ah, it worked.
Perfect.
Okay. So let's see. We wanted to actually deploy something on our cluster. Here also started, but
wait, let me do this.
yes. Okay, yeah.
That looks pretty red.
Yeah. Let me do Cradle. Let me do that. Because it says unsupported class version error. Ah, I know what I didn't forget. I have to tell IntelliJ that I want to use a JDK 17. when I tell Gradle to build Java 17 code and I use a JDK 11, then yeah, well, that's not gonna work. Yeah. So yeah, so that was that. I see we have a new follower.
Yeah. Oh no!
What did you do? I hope the stream is still there.
I gotta be kidding.
Should I come over? We have minor technical difficulties. We fixed them. Okay.
Great. Perfect.
Moritz just signed out of the streaming computer.
I hope we're still streaming and it's still working.
Yeah, it looks like we're still
He
streaming.
thought the line, yeah. Sorry for that.
Yeah. Where was I?
Yeah, so just back to my point, I was gonna welcome Hungry Mind Official to the chat, but I don't know how to do the @ sign, and I guess I did it wrong.
Yeah.
So yeah, okay. Back, you had to set the correct
JDK.
JDK, yeah.
IntelliJ, yeah. So now it works.
Perfect. Okay.
Okay. Let's get really to our task at hand. If you remember, we built a Helm chart here, and we have some values where we can configure basically our Helm chart. We specify the image. As we said before, this is currently my private repository, which is public, but not a company repository, because there we have the no public images policy. We will later want to, at the moment we have the tag latest, and we have the pull policy if not present. This will basically mean the image will never be updated, because the latest image is already there, and Docker sees, okay, it's there, so I don't have to pull, because you told me only pull if it's not present.
Okay.
So if we want to use really latest, which you shouldn't, it's only for testing, it's easy. So I don't always have to copy the SHA from GitHub and so on.
Okay.
Then you can use always here. Then it will always pull when it starts a campaign.
Okay. Every time there's a new image, then okay.
Yeah, not or every time there's a new image, every time a pod starts.
Okay.
Which is not what you want in production, because if you pulled the same image once and you want to start 50 containers or 50 pods, then you don't want to put it 50 times.
So what would be the normal settings in production?
Normal settings would be if not present. And in our deployment step, we will replace the latest here with the tag.
Okay.
So if you remember, we I put it up a bit so you can stay.
A little more room, yeah.
We installed it manually last time with Helm upgrade -1 is install, because that works also when it's the first time. We specify the namespace in which we want to deploy it. In our case, it's movie time. That's just the namespace we got. The Helm chart should be named movie time BFF. You can choose whatever you want, but I think it makes sense to use the same name. Then we specify the path to the Helm chart, which is in here. And then we can, with the -set, we can change some properties. So for example, the API key for the movie API, which we currently have set to configure me. We want to set it to the contents of my environment variable. I just use my environment variable, so I don't share my secret key here.
Of course.
Yeah. And now if we want to change the tag, we can just say image.tag equals, and let's go to GitHub.
Okay, just a short break for all our fans. We're finally back, and we have 2 subscriptions already.
Yeah, well, awesome. Thanks, Flexer and Greenery. I hope I pronounced it half right, at least.
Crine?
Greenay?
Crine?
Ah, right. So, if we want to change the tag here, whatever, that's also good. In the future, I try to call you whatever. So now we set the tag, and we can also have a look in Lens. We are quick. We see this is the old pod running in Kubernetes, and this is the new pod that is now starting.
Okay.
Because we changed which image we want to run from latest to that number, and it's now running. You see it went green, so the readiness probe that we implemented last time was said it's ready, and the old one is terminating. Because Kubernetes saw, okay, the new one is now running, so we can shut down the old one. And yeah, that's it. Now it's gone. So we have updated basically.
Okay.
Seamlessly. So we first start up the new one, and when that's ready, then it switches over the load balancer to the new one, or basically adds the new one to the load balancer, then removes the old one from the load balancer and shuts it down.
Okay.
So the user should not have noticed this at all.
But this is the manual steps you do.
Yeah, that's basically manually doing it.
Okay.
We want to automate this.
Okay, perfect.
So what we can do is we go to our GitHub Actions, and we need to add another step. And there are, so for every GitHub action, there's like 10 possible GitHub actions that you can use, especially for the ones that are not directly provided by GitHub. Unfortunately, Helm is not directly provided by GitHub. Obviously, always be a bit careful when you use such a task, especially in our case with Helm deploy. We will need to provide it secrets to access our Kubernetes cluster with some admin rights because we want to start pods and stuff.
Okay.
So we cannot, we should check that it's not sending our keys to somebody else or so.
So how would we check for that?
You can go to the GitHub and have a look. I mean, yeah, that's basically what I did. Here's the chart. So you have some YAML that defines, no, that's a Helm chart. What? The workflow, yeah, sorry. That other was an example. So here you can see what happens. It creates a Docker with Helm.
Can you increase the font a little bit?
Yes. Oh.
Wow. Okay.
Yeah, it builds a Docker. Probably the Docker file is also in the repository. I have to check again, and then run some command in there to set the entry point and so on. It installs Helm 3 and also Helm 2, so you can use both. Yeah, and then basically you just can run Helm commands in there, so it's no big dark magic. No.
Okay. So you don't only look for stars on the GitHub action or anything. You will actually look at the code to make sure it's not doing any funny business.
Yeah, I mean, when it comes to admin credentials, I think it's worth checking.
Yeah, of course.
So here you see the Docker file that it's creating. So it's basically an Alpine, getting Helm, both Helm versions, adding some curl and stuff. AWS CLI if you use AWS, and then runs the index.js, which you can also have a look, and so on. Obviously, if it has more stars and no issues that say this is a scam, it also helps. So you can start by checking that.
Okay.
But yeah, we want to use that. How can you use that? You go back to here. And you can here use latest version, and basically that's what you need to add. Here it's especially important to use this one here because the README is actually wrong. I noticed. It's a fork from originally this one, but this one hasn't been maintained since 1.5 years, so they made a fork, but they didn't update their README to actually point to their version.
Okay.
So we're gonna use what I just copied and deploy to Kubernetes. It's also a good idea to use that version because then you have that version and it's not changed afterwards. And now we can have a look at the README here, what's actually usable, or what we should do, or we could check the example here. So we can define some config. What we probably want is like, yeah, let's start by copying this. And then we can throw out what we don't need. So obviously this is not Nginx. This is the name of our Helm deployment. So if you remember what happened, the command here, it's this part, the movie time BFF part. The namespace was movie time. The chart is Helm movie time BFF, the directory in the repository. The GitHub token is automatically provided. The values, we will change that. We don't need to add additional values files. So you can also provide additional files. And what they demonstrate here is you can have like a common values file, which we also have here. But we directly have it in the Helm chart. And you could then add other ones. So you could have a separate one for production, one for staging, and so on. Yeah, so you can do this, and basically what's in here would override this.
Okay.
Stuff in there, yeah. but we don't need that. And the environment, the kubeconfig file, which is needed for kubectl to access the cluster and for Helm. And we will need to provide that. We will come back to that. So values. Now we need to provide basically what we said here. Okay.
What is I'm saying? Which one?
Sorry. Here in our command, everything that we want to override.
Okay.
Important note: it's not like this. It doesn't work like this. You have to put YAML in here. It cost me an hour to read the doc properly and find out.
Oh.
Yeah. Because I was like,
great example.
Of course, yeah. The example was only like name.
Yeah.
So you cannot see it directly.
Yeah, great.
And yeah, I just copied it. It must work like that. Why not? But yeah, the doc actually says it, but obviously you don't read it that closely.
Yeah.
Yeah. So here
what does the pipe do after values?
It says that you put in YAML.
Perfect.
So basically, it's just everything that's coming in here will be interpreted as YAML.
Okay. And
it can then use it as YAML. Yeah. So I should have known, but yeah, should have. We obviously also want to set the image tag. So we can set this to the GitHub char.
Does this work? Is this the same?
Yeah, that's the char. Really the char.
The same syntax as above. Right?
Yeah.
Okay.
It's the same syntax. Yeah. It basically, before it puts it in there, it evaluates these variables.
Okay.
Yes. Now we will get one problem, and that is that in the container registry that we can access, which is my private one, we don't have the char for this other repository. I just now realized this. Yeah. So we can do. Let me have a quick think. I will switch to the other repository, so we can actually push it. And yeah, let's go here. So it's same code, just what I prepared. Or basically I now switch back to the same version. I add this here, our Helm deploy. Great. So now movie time DB service. We also need a secret here. Not with that. And we will just call this the movie DB API key, I think, if I remember correctly.
What's the convention on how to write this? Now you have three different ways of writing it. You have it in small letters, so capital snake case, and capital. What's the right way to do it?
Yeah.
Or is there?
So actually, you should probably do that.
Okay. The GitHub char is something you can't change anyways, right?
Yes, that's automatically coming from them. I use this writing here because it's basically, to me, it feels like environment variables. And for them, you usually use that.
Okay.
That's basically the only reason.
Okay.
But you can do it like you want. Yeah. Now we have defined these. We need to set them also. And for this, we can go to GitHub. In your repository, you can go to settings. Then there's secrets. And then for the actions, you need to set the secrets. And you see here, I have them already set. let's see, can we? No, we cannot. Because, yeah, obviously you cannot see them. That's good. I knew
but
that.
you can't update the name.
Yeah, that's what I wanted to test.
Yeah.
So we will stick to the old name.
Okay, perfect.
Just to keep it working. Yes. So, however, there's the question, how do we get to this kubeconfig? So obviously I have one because I can access the cluster. No, I can do kubectl pods and stuff like that. So I have access to the cluster, and I was also able to do the Helm deploy. So actually my user is an admin user for the whole cluster, which is probably not what we want to use for the GitHub Actions.
No?
To give it like super admin rights. Yeah. So there's a concept of service accounts.
Okay.
In Kubernetes, and there's a role-based authentication. So if you want to read about it, there's a lot of documentation about it. That's really complicated. Again, like always, in Kubernetes, when we want to have something, we define it in this YAML format. We tell Kubernetes what it is, and we define how it should look like, and Kubernetes will make it happen.
Okay.
It's the same with the pods and stuff, and it's the same with roles. So what we're gonna do is we're gonna create this here. I already prepared this YAML. We will create a service account. This service account will be called movie time GitHub Actions. You can call it whatever you like.
Okay.
Important is we set the namespace because I want to make sure this service account can only work in this namespace.
Okay.
There's a lot of different namespaces on this cluster for other projects and stuff. This GitHub Actions should only be able to deploy in there. So if the key gets lost, if somebody gets it, it's only this namespace that can get destroyed. So then we have to define a role for this role-based authentication. And here we can tell what it has access to. So you can define multiple here. So at the moment I say all endpoints, all resources, all methods that you can apply are allowed for this one, but only in movie time, only in this namespace.
Okay.
You could also make a read-only user by specifying only read-only verbs here. Yeah, like this one. Get watch list. Then this would be, as you see here, the name reader. And it can only read pods. So it cannot read deployments, it cannot read secrets. So you could also make it possible that the user cannot read secrets. But we need it to read secrets because it needs to edit the secrets.
So would it be possible to narrow down the privileges so it can just do the one thing it needs to do?
Yes.
And is it good practice, or would you rather leave it open? So
it depends, obviously.
Okay.
In a production system, probably you want to narrow it down as much as possible. For me now, the most important part is it cannot get out of this namespace.
Okay.
So if something happens in this namespace, I don't care, basically.
Okay.
I mean, obviously they could deploy some pods that do some mining or something, which we would not want, but we could then kill this again. It's not like they can destroy important data also.
Okay.
And I also don't expect this key to get leaked by GitHub, but yeah, making sure is always better. Yeah, for example, you could also define a user that cannot access, or we could say our user can only access the secrets for the movie time BFF, and not like the certificate secret that's also in the namespace for the SSL stuff.
Okay.
And so on. So the role is still too big, basically, for what it needs to be, and narrowing it down as much as possible always makes sense from a security point of view. But obviously, it is also quite some work to add all the resources and
yeah, sure. Okay.
And then when you update something, you need to change it again. But Still, it's a good tool.
Okay. Do you normally have more than one role? Like,
You could have, because you could define like a reader role, and you could define a deployment role, and then
Okay.
you could say this user, the GitHub Actions user, has to read some stuff and it has to deploy, but another colleague who should not be able to deploy directly, he might only get a reader role.
okay.
Then he can read everything, but he cannot change the deployment. Because a normal developer might not need to change the deployment, especially in bigger companies. You usually don't get write access to the production cluster.
What? You don't?
Yeah, and also there's some requirements by law that not everybody has access to all the data and stuff.
Okay.
But you still might need to read the logs or see if pods are crashing and stuff.
Okay.
Yeah. So it can make sense to have read access only.
So in the project you were in,
Yeah.
do you have one role or do you use multiple roles?
Actually, I don't know because I didn't configure them.
Okay.
I just got them. I know in staging I have access to have also write access for some stuff. In production, for example, I cannot read secrets, but I can read config maps.
Okay.
Again, that's also what we try to do with our config map and secret split. In the config map, you have like a log level, database host, port name, and username might be that's not the relevant information or the secret information. And in the secrets, we have the really secret stuff, like the API key, database password, and so on.
Okay.
And that's helpful to make the separation.
Write access only.
Yeah, write access only. Yeah, so now we have the role, we have basically the user, the service account. And now we need to make a role binding, which connects them together.
Okay.
And yeah, this has a name, it's also in the namespace. It references this role, which is of kind role. There's also cluster roles, which are cluster wide and so on. So there's different stuff, and this is the name. Then we say the subjects, the users that it applies to, or the service accounts. And here it's a service account and with the name. Okay. And now we can just apply this to the cluster. This is in, I put it in helpers, and then movie time, GitHub Actions YAML. Yeah, I had it already in the cluster, so that's why it's unchanged.
Okay.
But that's basically it. Now we have a service account there. Now we need to get credentials for it that we can use.
Okay.
If you are in the cluster, then it's enough that you could say a pod has access to the service account, then it automatically has this service account. And then you could from one pod you can manipulate also Kubernetes what's running. You could start new pods and stuff. We did this one in a project that we had like a master or a manager pod or a service, and you could say, hey, start me like 50 containers of this type. Actually, we set up a whole infrastructure with multiple containers that were connected with ingresses and so on that you can reach from the outside world and so on. And with one click, everything started. 50 pods starting. It's really cool. Yeah. So now we need to extract the secret from Kubernetes, and that's a bit of a pain. That's why there's a script. I found this online. And I have to see where it was a Stack Overflow thread. I have to put a link in there to probably name the guy. So basically we just put in some data, cluster name, movie time. The server is a different one, but I don't want to share that with you. That's basically the server, the address of your managing server for Kubernetes.
Okay.
If you want to know these details and you already have access, then you can look into your kube config. And there you will find it namespace in the service account we just created. And what it does is basically it does a couple of kubectl commands. For the service account, it gets the secret, and in the proper way, it gets the certificate. and it gets a token. You need all these three, and then it prints it in this format that kubectl needs.
Okay.
And then I put it into this file.
Ah.
And when I now helpers as great. When I run this, then I have this file here now, which I will not open because it will leak the credentials. So I better delete it directly so you cannot see. But you would open this file. You see it has exactly this structure. And you just copy paste the whole file. You go over to GitHub, the wrong one. You create a variable, kubeconfig, or however you named it, maybe with a dash or underscore. And you put in the whole file content here.
Ah, okay.
It should look really like the file, not like minified or so. So really like the file. The structure needs to be the same.
Okay.
Yeah. So make sure of that you don't lose some new lines or something like that. Yeah. And then you save it. Here I also just created a secret with my API key. And with that, we should be ready to go. Let's see. We added this here. Yeah. Let's try. I will commit and push this. So, action. It looks like I
didn't quite work.
Messed up. Test and mapping was not expected. So that is a syntax error basically. Uses probably
71.
What?
Didn't say 71.
71.
I thought
I actually didn't look. Line 71.
11.
Does it need a new line? I mean, it's YAML. It's all is possible. Yeah, maybe it's actually the new line. I really hope not, but come on. Oh no. Okay. Then let's see in my
Mapping
branch.
was not expected.
Let's have a look in my branch where I tested it. What is different? Let's put that here.
Why is it so much longer?
We will get to that. Come on. Okay.
What?
That must not kill it. What's wrong? No, I hope it's not that.
Would be funny because we said, okay,
yeah,
this is how you name it normally, but they didn't.
Yeah.
Oh wait, you used something.
No,
No,
still not. The workflow is not valid. Testing.
Look at it. 70 line 71:11. Is that the end of the?
No, that's the beginning. It's the beginning.
That's the beginning. So there must be something wrong.
But I just copied over the code. Thanks for the subscribe, half survived. This is probably something really stupid.
Probably.
It always is.
But the test Helm branch you have is this one is working, right?
Yeah, that one.
So the code is actually.
Yeah.
There must be something wrong there. You have a hall. I have a hall. What? Why? I don't get it. Oh, did we move the... No. We didn't move the microphones?
Ah.
How am I supposed to get rid of a hull? An echo, I guess.
I have no idea.
Okay.
Um,
Felix, if you're still watching...
Audio is fine for me, he says.
Okay.
So,
Half so wild. You're killing it right here.
Let me check. No, it's Linux line endings. Huh? Oh, was it really Windows line endings? Yes. Line endings. That could be actually the case.
What?
No.
I missed it. What? What was the issue?
Contents have to. Not sure. No. I thought the line endings would be different, but they were actually the same. Let's copy over the whole thing. No. Let me get the whole thing. Okay.
Okay, Chris, maybe you can come in and say if the audio is fine.
Make a vote.
Yeah.
Audio fine.
If it's just half so wide, then his hearing is extremely good.
Then we just ignore.
Oh. No comment. No comment.
You have 2 tabs open. I mean, it's nice that we get more viewers, but that's a way to increase
That's
our viewer
the
count.
internal strategy. Just open 10 tabs. Keeps the audio on.
That's amazing.
Hello, hello, hello. Sorry, Hungry Mind, I totally forgot about you.
Yeah. So what is different here? What's the... Oh, I have an idea. It could be that it's... Is there a tab in there?
How can you...
I have no idea, but it's more stiff.
Wait, now you're one level below.
That was the issue.
You're supposed to be on width or you're supposed to be on values?
On width.
Okay, then that's the
Ah, come on, I hate YAML. That's so terrible. Are you supposed to know and see that?
Oh. I'm not even going to respond with a proper thing for this half so wild. This can happen to anyone.
Yeah.
It's YAML. It's not just like Python. If you lose your
if you use the indents, you're
dead.
screwed.
You're dead in the water.
Roll back and try again. I really hate it in Python when I always use auto-formatting in IntelliJ. And when you mess up the indents once, and then it kills all the rest of the code because it fucks up the indents, then it's really, really bad.
That's why I love PyCharm to write Python code, but the first thing I disable is autocorrect, because it just, if you type something and you want to move it to the next and you still know where you are and you want to move it one tab to the right, it will autocorrect something and then you're done.
Yeah.
That's just, yeah.
So
Okay.
Actually, we're it's working now. At least the building. Let's see if we got lucky and it works the whole thing the first time. If not, what I usually tend to do is comment out all the building and check and building the container.
Okay.
Because this takes like 2 or 3 minutes, and I don't want to wait when I have to really debug the Helm thing. Then just remove all the other, use latest as the tag instead of the commit chart. And then at least you can see if the Helm stuff works.
Okay.
And the Helm task works. Otherwise, you always have to wait 3 minutes and you get crazy with that. A little recap. What did we do?
Are you talking about the indentations in YAML files?
Indents in YAML files are crazy. No, a little recap. What we did. We want to deploy our Helm chart that we have in the project here. We want to deploy it to GitHub, to our Kubernetes cluster with GitHub Actions. And what we use here is this GitHub Actions task. We configure the release here, which is basically the name of the Helm chart later. We say we want to have this namespace. We select the chart in our repository, provide a GitHub token, which is auto-generated and provided by GitHub. Then we provide the values that we want to override. It's important, this has to be YAML. So this is basically when we look in our values YAML, up here, this is image tag, the same structure like here. That's actually good that we have the same structure. We override these values. For secrets, we use the GitHub Action secrets, which is this one, which we create in our repository. And we provide the kubeconfig, which we also provide in our repository on GitHub, and then it should work.
And it looks like it will.
Yeah, now we are at the deployment phase. Let's have a look at the cluster. At least we got to the cluster. Something's changing. It's up for a couple of seconds. Let's have a look at
Hasselwald, I'm pretty sure it's not what you meant. I know what you meant, but I'm not sure how we can do this. But we will try to do a 30 to 45 second recap on what we do in the end.
Okay. Connection to movie time DB database refused. Check the host name. Why? Oh, the DB also was recreated. Interesting. Problem.
Why?
It's a good question.
Did you upgrade No, you already did it once, so shouldn't the upgrade for the version was the last one, right?
Yeah. Probably the Helm chart got updated, and in that the Helm chart of the database got updated, and so on.
Okay.
I assume it was that. So now status down. Okay, data connections have check status down. Default unable to access. Okay.
But it looks like it's running.
Yeah, it looks now like it's running. So let's just see. BFF, yeah, online. Yeah, it's running. So it was only down in the beginning. That was actually the readiness check.
Okay.
So you actually see the readiness check in action. At the beginning, at the beginning, Quarkus was complaining that it could not open the connection.
Okay.
And then it could, but the database, it was there, but not ready yet.
Okay.
So the check was still down. And now after...
But there's no message in the end, okay, everything is fine, go ahead.
It's green here.
Okay, yeah, right. Okay.
Otherwise, if it wouldn't recover in time, then the liveness probe would kick in and would kill the pod and might restart. Okay. Also, the database down thing is not a liveness probe, because if the database is down, it doesn't help you to restart your pod. It will not make the...
Okay, yeah.
It will not make the database alive to kill my BFF. It might only stress the cluster when it might already be stressed. So we don't want to do that. So we just wait and we say we are not ready. And it might be, if we have multiple pods, that only one pod is disconnected, because we are running on different nodes. You see here?
Okay.
These are different computers,
Okay.
different servers. So it might be there's a connection issue in the network, and it just cannot reach the database because some switch is broken or whatever. Okay. So it might be that one of them cannot reach it. So he's just waiting until it gets better. And the other ones will still be in the load balancer and will still serve the customer.
Okay.
Because in production you don't run with one pod, you run with multiple. Yeah. So that's all the screen here, and we have deployed to Kubernetes.
Pretty cool.
Any questions? I'm happy that it works.
Yeah.
If you don't have questions until now, I have an extra thing that we can still add. So
that's extra length in the YAML file, right?
Yeah, yeah, that's the extra length in the YAML file. So if we look here, red. We have build and push. This is one job, and in here we do all the steps. We build a container and so on. But we can also make multiple jobs. So this Helm deployment here, it does not depend on like the JDK and actually the building of the container.
Okay.
It could be a separate job, and it might also be that we don't want to run it always. It might have different conditions. So probably we only want to deploy to production when we actually push the main branch or add the tag or something like that. But we might always want to build a container and push it so we can maybe use it on another stage. At least building container would be interesting to see that still works. So what we can do is we can actually upgrade this to a job. And a job is just one level higher. This one is called build. Yeah. And basically we just need to copy paste it. Let's start with that. In front of here. And deploy. And runs on Ubuntu, okay, and then what was it called? Steps must be here. Okay. However, we also need the code because we need to have our Helm chart. So let's just get this checkout task. Okay. So one nice thing about jobs is that they can run in parallel, and they will by default.
Okay.
So especially maybe we would want, it makes not much sense for us to also build it with Java 11. Maybe we have some legacy system where we also need Java 11, or we have an upgrading phase where we want to test it with Java 17 or whatever you can think of.
Okay.
So you could run both in parallel.
Okay.
Build with Java 17, build with Java 11. But in our case, it's better if the container is built before we want to deploy it.
What?
Yeah.
Otherwise, it would be magic.
Yeah. Pulling before it's there. I mean, it can work if you wait long enough, because Kubernetes will retry and retry, and one moment it will be there and then it will work. But also this Helm chart here, it has a timeout.
Okay.
So it waits until the deployment actually worked, and if it doesn't work, it will abort after the timeout, and it will roll back the Helm chart to the old version.
Okay.
So if you don't know, there's Helm history.
You
need to movie time BFF. You need to say for which Helm chart, obviously.
Okay.
Just testing. Yeah, you see here we didn't update the app version, but never mind. You see the chart version here. You could also see if that changes, and you see all the revisions here.
Okay.
You see which is currently deployed. You see this one failed. And then it was cancelled, and then probably rolled back.
Okay, there's cancelled. Okay.
So if I would go back to here, and instead of the image tag latest, I do something that doesn't work.
Why wouldn't this work?
Because this tag doesn't exist.
Oh, okay.
I added a letter, latest D. So just it's a tag that doesn't exist.
Okay.
So now the Helm chart was updated, and the Kubernetes deployment YAML was updated, and Kubernetes tries to start this. And we can see down here, fail to pull image.
Not found.
Yeah, because the tag is not found.
There it is. Okay.
So now we could go to our history. It's still saying the new one is deployed. Because, yeah, for Helm, this is done now.
Okay.
This action here is a bit smarter and checks if it's really worked in the end.
Ah, okay.
So you could also do this with commands, but in our case, we just see it doesn't work. So we could now do a rollback manually. Rollback, I think it's like this, give the revision, and then we BFF again, number. Okay, then it's the other way around. So now we roll back.
That's 56, that's the revision, right?
Yeah, that's the number
Okay.
here. Rollback success, and if we check the history now. Wow, that's really fast today. So you see here, there's a new revision 58, and the comment here is it was a rollback to 56.
Okay.
And our nice action here, it has this atomic flag. If true, upgrade process rolls back, changes made in case of failed upgrade. Defaults to true, so we don't have to set it. And there's also a timeout field where you can specify the timeout. So you might have a real big deployment, like 50 pods, and they do rolling updates, so you need to wait longer until it's really done.
Okay.
Because it's only a success when all of them have managed to update. And when you have 50 pods and Kubernetes doing a rolling update where it starts 5 new ones, then takes out 5 when they are started, and it does this rolling update, then it takes some time until this is done. So you could increase this value here.
So the atomic part tells you if you
either you update
upgrade
works or it fails and it rolls back.
Ah, okay.
Yeah.
Oh,
so it does this rollback for you, which is really nice. So you always have a stable version running.
But you set it automatically. You set it to false, right? So you can show
no, it is automatically true. Defaults to true.
Okay, but why did you have to? Oh, it wasn't failing, right? Okay.
Yeah, right now I manually did it.
Yeah.
I deployed something manually. It has nothing to do with this GitHub action.
All right. Yep.
You keep in mind. Have to keep in mind that that's about the GitHub action, and I used Helm directly.
Okay.
So now we want to make this deploy task. We check out stuff, and as I said, we want to make sure this is waiting for the other tasks. So we can say needs build. And if you have more jobs, you could also think the syntax is like this, and do another. So you could wait for multiple, and then you basically can create a directed acyclic graph.
Ah, okay.
So you can really parallelize your tasks easily.
Nice.
So yeah, let's try.
I think you still need the needs, right?
Oh, yeah. Just wanted to demonstrate how it works. Not.
Okay. So if you don't put this in, they will both trigger at the same time, right?
Yeah.
Okay.
And then probably because the timeout is not so big on the Helm job, it will timeout and roll back before we manage to build the container. So that wouldn't be in our favor. And also makes no sense to do it before that. No. Yeah. Yeah, make deployment a job. And when you look here, you see this graph.
Ah, nice.
Okay. You would see multiple here, and for bigger projects, this can grow.
Okay.
So this should work the same because we basically run the same. In here, I don't know if you can. Yeah, we cannot look into it until it's run.
Okay.
Yeah. Yeah. Any questions left for the Kubernetes Helm Quarkus GitHub Actions series? Yeah, bullshit bingo. No, to recap maybe the whole series, what we did is we created with Quarkus, we create the container, we push it to the GitHub registry. We use Helm to deploy our service with a database, with ingress and the service, with SSL certificate to our Kubernetes cluster. And yeah, now we finished it up by using GitHub Actions to actually deploy it to the Kubernetes cluster with Helm.
Okay.
So
yeah, I don't think that's. I have no idea. I talked to Hubsawald today about the shorts, and I'm not sure if this is the correct format for it because it's a really complicated and complex task you do, and in the end, it's really nice to have it all done, and you will actually know when one step of it will fail.
Yeah.
So that would be nice, but basically you set it up once and then you forget about it. Hopefully you have some good documentation saved so you know what to fix when it's actually broken, if you actually broke something, but normally you set it up once and that's it.
This is your documentation. No, yeah, one important thing is obviously this creating the service account and getting the secret. In a production system, somebody would provide you the secret, some admin or so, or SRE team. If you set it up for your own, you can do it like that. I mean, it's the same steps. Now you have a feeling for it, what's behind it, what you can do. And for me personally, getting this set up is like the highlight of. It's really a big highlight of a project because it makes your life so much easier. I also did this for a private project a while back, and whenever I push something, it's just 2 minutes and it's running on my server, and it's amazing. I don't have to touch anything with Docker and stuff anymore. It just works out of the box, and that's really cool. And with GitHub Actions, you get 2,000 minutes of build time a month for free
on Linux.
GitHub. Even with private repositories.
Yeah, but only for Linux systems.
Yeah, for the Linux systems. For Windows, I think it's factor 5. So for 1 minute you run on a Windows machine, or with a Windows image, you have to pay basically 5 minutes. And for Mac, it's 10, I think, if I remember correctly. So still 200 Mac minutes.
Yeah, but Mac's really expensive. So iOS builds, they're basically impossible. I know at my last project I was in, they used GitHub and they optimized everything, which was really, really nice.
Yeah.
But yeah, those are expensive.
Yeah, those are really expensive. But for like server stuff, it's crazy what you get for free.
Yeah.
Basically, I mean, I don't have to pay any build server, so that's really good. Thank you, GitHub.
Yeah, it's actually pretty cool. So I learned from the last few streams you did, and I also applied a few of the GitHub actions to my setup with Vapor, and it works perfectly. The Kubernetes part doesn't.
And now you know how to do it with Helm.
Yes, but the main problem is I don't get any pods. I have Docker Compose right now. So it's really easy, but it's a little bit more complicated if you want to scale it.
Yeah.
So.
Yeah.
Okay. But that's awesome.
So I guess no more questions. So thank you for joining in again. Just a reminder, if you have missed the couple of episodes before, they are all on YouTube, on our YouTube channel. This one will also be there. And yeah, happy coding. Thanks for watching.
Thank you.
Bye.